Welcome back, Science 10. This is the 8.9 investigation in the CR5 section, Quantitative Neutralization, and it's based on pages 314 to 316 of the text. I've changed it slightly, so there'll be a little bit more to discuss with the pre-lab with this. So what you want to find out what the purpose is, to determine what happens when an acid reacts with a base, and also to detect when an acid has just neutralized a base. And we'll have a visual clue as to when that happens. Okay, so the hypothesis here, I kind of helped you out again here. What do you think will happen? So something along the lines of, I believe that an acid and a base is a neutralization reaction. That should be IS, not IN. Kind of looks like an N. I will know that neutralization has occurred when the color has changed to a very light pink. So what we'll be using is phenolphthalein, and it's an indicator that's colorless in an acid and hot pink in a base. So if you kind of go in between colorless to hot pink, a very light pink would be smack dab in the middle at a pH of 7. So we're looking for a very light pink color. That would indicate that it was neutral in between acid and base. To help you with the background questions, what is neutralization? The reaction that occurs when an acid completely reacts with a base. And then what are the products of a neutralization reaction? An acid and a base yield a salt plus water. And by salt, I don't mean table salt. I mean an ionic compound, a metal and a non-metal. And as we'll see here, the metal of the base combines with the non-metal of the acid to make that ionic compound. So number 3 here, that kind of addresses that. What is meant by the salt of a neutralization reaction? So it's the ionic compound made from neutralization. So here I have hydrobromic acid, sodium hydroxide base, and you can see what happens here. It's a double replacement. The metal of the base combines with the non-metal of the acid. In this case, Na and Br come together to make NaBr, and H from the acid and OH from the base make good old H2O. So it's relatively easy to come up with that equation. So what we're going to be using here, hydrochloric acid is going to be the acid, sodium hydroxide is going to be the base, and that big long word there, the phenolphthalein indicator. And of course goggles. We're dealing with acids and bases here, you definitely have to wear goggles. So the procedure here is a little bit different than what's in the textbook. So I want you to measure out 20 drops of sodium hydroxide into a test tube. So just using a dropper, actually count out 20 drops. Add 1 to 2 drops of phenolphthalein. All you need is 1 to 2 drops, that's it. And you'll see that this is the base, and in a base, that phenolphthalein is going to be hot pink. So you'll see it turn hot pink immediately. And add hydrochloric acid drop by drop, and be sure to shake and mix after each time. And of course you'll see that pink color get lighter, lighter, lighter until it's just a very faint pink. That's the color that you're looking for. Almost colorless, but still a little tinge of pink. So do this until the color just changes. This is the point of neutralization. Because we're dealing with a very small amount here, it won't take that much. Repeat until 3 trials have been done, and then take the average number of drops that you used. So do this experiment 3 times and then take the average, as you'll see on the next page here. So using the same amount of base at the start, 20 drops of sodium hydroxide, how much acid, how much acid, how much acid, and then add up to 3 trials, and of course to find out the average you divide by the number of trials. We have 3 trials, so we divide by 3 and we get the average. And then as usual, what we're going to do, the purpose was to and what did you think would happen? It was thought that, and what did happen? You can explain that there as well. And then only a couple of questions here. What was the purpose of phenolphthalein? And then write out the equation of neutralization in this experiment. So I gave you a little hint here. We're using hydrochloric acid, sodium hydroxide. Those red circles there are a huge hint, so you should have no problem with that. Okay? Good luck with the lab.